In a world where data has become the lifeblood of businesses, research, and innovation, managing and harnessing its power is more crucial than ever before. HDFS, a fundamental component of the Hadoop ecosystem, stands as a robust and scalable solution designed to tackle the challenges of handling vast volume of data. Imagine a warehouse housing all the data and information we are storing and will be fetching it whenever needed. HDFS is that warehouse, allowing us to store, manage, and retrieve data with high efficiency and reliability. In today's video, we are going to cover everything you need to know about HDFS algorithm. But before we begin with that, I would like to request you guys to enable both subscribe button and bell icon to come across multitudes of updates from Intellipaat YouTube channel. First of all, let me take you guys through the agenda that we have for this session. We will start by understanding what HDFS is and why it is used. Then we will try to understand the algorithm it uses. During this particular section of the video, we will learn about a few key terminologies involved in the process of HDFS algorithm like file storage and blocks, data replication, name node and data node, data read and write, replication management, scaling and balancing, rack awareness, and consistency model. We will also be learning about the ways we can access HDFS. Then we will move ahead to put all these pieces together to understand the architecture of HDFS algorithm. And with this, we will finally conclude our today's video on HDFS algorithm. I hope I have made myself clear with this agenda. So let's dive into the first topic on our list. What is HDFS and why do we need it? With this ever-growing world, the size of our day-to-day data is also increasing. This huge amount of data generated from social media, websites, telecommunications, etc. is known as big data. Due to its massive volume and longer processing time, storage and processing of big data proves to be a challenge. These problems are tackled by HDFS. The Hadoop Distributed File System or HDFS is the primary storage system used by Hadoop applications. It is a distributed and scalable file storage system created to manage enormous volumes of data across a cluster of commodity hardware. Now some of you might be wondering, what is a commodity hardware? Commodity hardware, also referred to as off-the-shelf hardware, is a type of commodity hardware that is widely accessible, reasonably priced, and essentially interchangeable with other hardwares of its kind. Almost everything you need to utilize or connect computing or IT devices, such as servers and cables, is considered commodity hardware. HDFS is an open source framework that works by rapidly transferring data between nodes. The Apache Software Foundation developed HDFS, which is extensively utilized in a variety of sectors that deal with large-scale data processing, including web businesses, banking, science, and other areas. The issues associated with storing and processing such large datasets are addressed by HDFS. This is accomplished by dividing the data into manageable blocks, distributing those blocks across several servers, and guaranteeing data redundancy for fault tolerance. This storage layer and other devices in the Hadoop cluster benefits from fault tolerance and high availability thanks to HDFS. Here is a simplified explanation of how the HDFS algorithm works. First, HDFS divides large files into smaller blocks, which are typically 128 MB or 256 MB in size. These blocks are dispersed among the Hadoop cluster's nodes. For example, if you upload a 500 MB file to a HDFS, it will be partitioned into blocks with 3 128 MB and a 116 MB block, totaling 500 MB in size. Meaning that aside from the last block, 3 128 MB blocks are generated. Hadoop treats the final file block as a partial record because it has no notion of what data is contained in them and is either unaware of it or doesn't care. Currently, Hadoop considers file blocks of 128 MB to 256 MB. This strategy makes data management easier and makes data processing and distribution more effective. After the data is divided into smaller blocks, each block is replicated several times to ensure fault tolerance and data availability. The term replication refers to making copies of something. The number of times something is copied is called its replication factor. Typically, the replication factor is set to 3, which means that each block has 3 copies distributed across several nodes, but it can be manually changed based on your needs. For instance, in the example above, we created 4 file blocks, which means that 3 replicas or copies of each file block will be created, totaling 4 cross 3, that's 12 blocks, all of which were created for backup purpose. Replication guarantees that even if a node fails, other replicas may still access the data. Now let us understand two most important terminologies or components of HDFS. HDFS employs master-slave architecture in which name node and data node are the two main type of nodes. In a Hadoop cluster, the name node serves as the master and directs the data nodes. The primary purpose of name node is to store metadata or information about metadata. Transaction logs that record user activity in a Hadoop cluster can serve as metadata. In order to locate the nearest data node for faster communication, name node keeps information about the location like block number and block IDs of data nodes as part of metadata. Data nodes are given instructions by name nodes for actions like create, replicate, and delete. In order to maintain or direct all the slaves in a Hadoop cluster, our name node, which serves as a master, needs to have a lot of RAM or processing power. All data nodes which are slaves send heartbeat signals and block reports to name node. The data nodes act as slaves and are in charge of storing the actual data block. There could be as many as 500 or perhaps more of these nodes. The amount of data stored by the Hadoop cluster will increase as the number of data nodes increases. In order to hold numerous file blocks, it is advised that the data nodes have a high storing capacity. According to the instructions given by the name node, the data node does activities such as creation, deletion, etc. In a nutshell, the structure of a data node looks something like this. A data node contains blocks of data and these blocks contain the actual data in them. Now when we are having a structure to work on, let us see how the client or user can write the data. To find out where to store the data blocks when a client wants to write data to HDFS, it talks with the name node. After that, the data is written to the data nodes, while the name node keeps track of the file's structure's metadata. When the client wants to read the data, it asks the name node for the data's location, and the data node then gives it directly to the client. Now we know that we can read and write the data into the nodes, but what if the node itself gets faulty due to some technical issues? The name node keeps an eye on the well-being of the data nodes. The name node flags a data node's blocks as being under-replicated if it fails or becomes slow. To maintain the appropriate replication factor, it then plans to replicate those blocks to other healthy data nodes. Now suppose we have utilized all of our data nodes, we cannot store any more data in our HDFS. Is that it? No more writing is possible but only reading can be done? No. Expanding our storage is as easy as adding a new hard disk or SSD to our computer. HDFS is made to scale horizontally by adding extra data nodes to the cluster. It rebalances the data when new nodes are introduced by transferring some blocks to the new nodes. By doing this, the cluster's processing and storage workloads are more uniformly dispersed. HDFS not only assigns data to the data nodes, but it also classifies data into racks based on the cluster's physical network topology. The rack is nothing more than a Hadoop cluster's physical collection of nodes, perhaps 30 to 40 nodes. There are a lot of racks in a huge Hadoop cluster. In order to perform read or write operation with the highest throughput and save network traffic, name node uses this rack's information to select the closest data node. This awareness facilitates the localization of data and lowers network traffic. For fault tolerance, HDFS seeks to distribute replicas across various racks, ensuring that the availability of the data is not jeopardized by a single rack failure. Another interesting fact linked with HDFS is its consistency model. HDFS offers a write once, read many consistency approach. A file's content is not supposed to alter after it has been written. Once a file has been created, written, and closed, only appends and truncations require modification. Although it is supported, adding content to the end of files cannot be modified at will. The reason behind this model is to reduce the problem of data coherency. It means reading or writing of the data at the same memory location, and it permits high throughput data access. HDFS does not, however, provide immediate consistency. Readers may encounter incomplete or incorrect data if a file is still being written and not yet closed. To interact with the file system, HDFS offers command line tools and APIs. These interfaces allow users and programs to manage and access data stored in HDFS. The Hadoop command line interface, or CLI, is one of the most often used methods for gaining access to files in Hadoop HDFS. With the help of the Hadoop CLI, you can interact with HDFS and carry out a number of tasks, including adding and removing files, listing directories, and altering permissions. You must have Hadoop installed on your computer in order to access HDFS using the Hadoop CLI. In addition to the Hadoop CLI, the Hadoop Java API allows you to access files in HDFS. You can programmatically interact with HDFS using a set of classes and methods provided by the Hadoop Java API. You must install the Hadoop client libraries on your computer and add them to the class path of your Java project in order to use the Hadoop Java API to access HDFS. Now we are well equipped with all the necessary terminologies related to HDFS. We understood what all components come into action while data is being written or read. Let us now try to put all these into one big picture. Our name node is the master component which holds metadata to the data present inside the data nodes. The data nodes are the slave components which hold the actual data. These data nodes are classified into various racks. The data present in these data nodes are replicated to ensure fault tolerance and availability. The name node orders block operations to the data nodes. In order to write data, the name node decides where to store data and allows the client to interact with the data nodes via CLI or API. Similarly, to read data from these data nodes, the client asks for the data's location from name node and the data is made available to the client directly through the data node containing the desired data. All things considered, the HDFS method is built to manage the storage and retrieval of massive amounts of data across a distributed cluster quickly while providing fault tolerance and scalability for big data processing jobs. Because of its functionality and architecture, it is crucial for businesses that process and analyze large amounts of data. That's all we have for this session. I hope you have got a good understanding of HDFS algorithm and how we can benefit from it. Thank you for being here till the end of this session. If you have liked this video, make sure to hit that like button and also consider subscribing to our YouTube channel to come across more technical updates like this.
Just a quick info guys, Intellipaat offers a data engineering course in collaboration with MIT MicroMasters. Through this course, you'll learn data wrangling, big data engineering with tools like Apache Spark and Kafka, data modeling, cloud data warehousing, and much more from professionals working in top companies as data engineers. With this course, we have already helped thousands of professionals in successful upskilling. You can check out their testimonials on our Achievers channel, whose link is given below in the description. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in this field of data.